This is a presentation of ME106 Mechatronics, San Jose State University, Professor Rahimi. The project is Electric Awning Window Opener with Gas Detection. Team members include Shensong Chao, David Nguyen, Pham, and Chao.
The purpose of our machine was to detect gas leakage and automatically open a window. The result was overall successful. The feature we had were triggering the buzzer, starting the fan, turning on the LCD screen, and opening the window. We recommend students to get familiar with Arduino because it is where we put most of our time in.
Description: LPG, or liquefied petroleum gas such as butane and propane or natural gas, are very common and essential in every household. However, the leakages are very dangerous and they can cause suffocation, fire, and explosion. Many homeowners have little knowledge in detecting gas leakages. This project aims to prevent fatal outcome caused by gas leakages.
For this project, we utilize and use various different mechatronics components. For our microcontroller, we went with the Arduino Uno. We chose the Arduino Uno because it was a microcontroller that we have been using extensively throughout the semester in lab. For our sensor, we needed a sensor that was capable of detecting both LPG and natural gas. With this in mind, we went with the MQ2 sensor. For our first motor, we had a 12-volt DC linear actuator. It had a stroke length of 4 inch and a maximum current draw of 4 amps. To control this linear actuator, we had a DC motor driver that was capable of controlling motor with voltage range between 5 and 25 volts and current range of up to 13 amps. Our second motor was a 12-volt and 0.08 amp fan. This was a PC case fan that we use as a ventilation system for our window system. To control this fan, we had an N-channel MOSFET that fed the fan a 12-volt power supply. The MOSFET is used as a switch and will only activate and turn on the fan when gas is detected. Our next mechatronic component is an LCD display. The LCD display is used to signal when gas is detected by the window, and a warning sign will be displayed on the LCD display. To control this LCD display, we have an I2C controller. We chose the I2C controller to control the LCD display because it helped with reducing the wiring and it made the coding much more condensed and simpler to read. And our final mechatronic components was the buzzer. The buzzer will be used to signal when gas is detected and while the window is opening.
The main analysis was done on the linear actuator. The window was designed to open up to around 30 degrees. Based on the weight of the window, which was 5 pounds, the required force calculated for the linear actuator was 8 pounds. The consideration was that there was no place for the linear actuator. Therefore, it sits at a bad position, which resulted in a mechanical disadvantage. The risk factor was that the linear actuator could break the wood frame if the linkage got stuck.
Test results. Since 8 pounds of force is required to push the window open, we chose an electrical linear actuator that has a maximum force up to 225 pounds. When the stroke on the linear actuator reaches its maximum length of 4 inches, we remeasured the window open angle. The result was 30 degrees, which was similar with our estimate. We experienced some difficulties in choosing the proper voltage source to drive the linear actuator. Initially, we used a 12-volt power supply in the lab and noticed linear actuator barely moved. After measuring the current, we found out there was only 0.5 amp on the circuit, which is too small to drive the actuator. That's why we chose a 120 volt to 12 volt AC to DC transformer as the power supply. We also tested the idle voltage and the threshold voltage on MQ2 sensor. When the sensor is sitting idle, its voltage reading is about 0.15 volt when there's no gas leak. The threshold voltage is 1.96 volt, so when there's a gas leak, the sensor will read greater than 1.96 volt. Overall, The MQ2 sensor works great when the concentration of leakage gas changes.
In conclusion, the system works, components are responsive as expected. The actuator were able to open and close the window. The LCD screen was able to display the warning message. The sensor were able to sense the gas leakage. The fan was able to circulating the air within the room. Moreover, all the components were programmed individually before being integrated into the system. This helped us to identify the problem with each component. Furthermore, MQ2 sensor is the most suitable sensor for this particular project because it has a built-in potentiometer. Time management is the key to overall success. We scheduled the project to be done mechanically by spring break, and from then we got some extra week for troubleshooting the system. A lot of knowledge and experience that we gain from this project can be utilized for our future project. Recommendations. Improvement can make in exhaust ventilation system. We can expand the design to other types of windows such as sliding, casement, and hopper. Improvement can make in power sources. At the moment, we're using computer to power the Arduino, an adapter 120 to 12 volt to power the fan. In the future, we would like to make the power source to be more compact, such as using 1865 batteries to power the entire system and being rechargeable by solar panel attached on the window. MQ2 sensor is being exposed to a butane gas source. LCD screen send a warning message. Fan turns on to circulate the air. Actuator turns on to open the window. When sensor stops sensing the gas, the system goes back to the initial position.